Good afternoon, and a very warm welcome to all the esteemed faculty members from various universities. I, Syed Rashid Anwar, Assistant Professor, Arkajan University, take this opportunity to introduce our speaker for today's session, Dr. Nishikant. Dr. Nishikant is an assistant professor in the Department of Biotechnology, Arkajan University. She completed her BTech in biotechnology from BIT Mesra. She completed her MTech from NIT Durgapur and also completed her PhD from ISM Dhanbad, uh, that is IIT. She has more than 3 years of teaching experience, and her broad area of research includes groundwater quality assessment and quantity management, hydrogeochemistry, remote sensing and GIS applications in environmental management, as well as health risk assessment. We welcome you all, and Nishi ma'am, kindly take over.
Hello, hello, hello.
Yes, ma'am, go ahead with your presentation.
Yes, sir. Good afternoon, everyone. Let me share my. Is it visible, sir?
Yes, ma'am.
So, on, on this World Water Day, I just want to present the presentation on topic availability and fluctuations of groundwater and its possible way of contamination in India, urban environment, and life in context of smart city. Water is life for all living beings on the Earth's surface. Groundwater is addressed as a necessary resource and life preserver. It is unevenly distributed on the Earth's surface, due to which some part of the Earth's surface will have excess amount of while other parts are having the scarcity of water. The hydrogeochemical processes, that is dissolution, mineralization, weathering of rocks, leaching of salts and ion exchange influences the quality of groundwater. On this note, I am starting my presentation. So, water is the most valuable resources to human and living beings, essential for the sustenance of life on Earth. The role of groundwater is very diverse. Hydrological cycle. Hydrology means the science of water. It is the science that deals with the occurrence, circulation, and distribution of water of the earth and earth atmosphere. As a branch of science, it is concerned with the water in streams and lakes, rainfalls and snowfalls, snow and ice on the lands, and water occurring below the earth's surface in the pores of the soils and the rocks. Water occurs on the earth in all its three states, that is liquid, solid and gaseous, and in various degrees of solution. Evaporation of water from the water bodies such as ocean and lakes, formation and movement of clouds, rain and snowfall. Stream flow and groundwater movement are some of the examples of the dynamic aspects of water. The various aspects of water related to the earth can be uh, explained in terms of cycle, that is the hydrological cycle. So hydrology finds its greatest application in the design and operation of introduction water resources engineering. Hydrological investigations for the proper assessment contains following necessary things: the capacity of storage structures such as reservoir, the magnitude of flood flows to enable safe disposal of the excess flow, the minimum flow and the quantity of flow available at various seasons, the interaction of the flood waves and hydrologic structure such as leaves, reservoirs, barrage and bridges. Groundwater quality. Now, groundwater is a key resource of water supply uh, everywhere throughout the world. It is evaluated at roughly 33% of the total populace utilize it for drinking purpose. It was appraised that each around 700 cubic kilometers water was removed by the world populace. Groundwater is a mere source of drinking water for many rulers and small societies. In India, availability of surface water is more than the groundwater. Pollutants brought together at the land surface may infiltrate to the water table and flow towards the discharge, either the well or a stream. Now, this is the zones of groundwater, the occurrence of the groundwater. Groundwater occurs in many different geological formations, nearly all rocks in the upper part of the earth crust, whatever their type, origin, or age, possesses opening called pores or voids. The volume of water contained in the rock depends on the percentage of these openings of pores in a given volume of the rock. That is termed as the porosity of the rocks. Moreover, more space results in the higher porosity and more stored in the water. This is the figure clearly illustrates at a very few percentage of uh, groundwater availability. Aquifer. Aquifer is a layer of permeable rocks with a high porosity that lets water move freely. Most drinking water comes from aquifers. Well, wells dug into the confined aquifers will give the most consistent supply of fresh water. Water flows in an aquifer the same way it would flow on the earth's surface. It flows down the slopes. Good aquifers include the sandstones, conglomerate, well-joined limestones, bodies of sand and gravel, and some fragmental or fractured volcanic rocks such as columnar basalt. Porosity based on the pore space connectivity, effective porosity. It is the measure of the void space that is filled by the recoverable oil or gas. In other words, we can say the amount of pore space that is sufficiently interconnected to yield its oil or gas. It is commonly ranges from 40 to 75% of the total porosity expect in unconsiderated sediments. Absolute porosity, the total void space in a rock, whether or not it contributes to fluid flows. Porosity on the basis of origin, it refers to the gaps, particles which forms during sedimentations. It is the void space that would be present if grains had not been altered, fractured, or dissolved. The amount of primary porosity depends on the several factors: the degree of uniformity of grain size, the shape of the grain, the method of deposition, so the manner of packing. Secondary porosity, it is formed by processes, that is recrystallizations or dissolving of minerals during, but the total porosity may be much less than the original porosity. Porosity usually changes with the depth of sediments as pressure of overlying. Clay in a particular losses porosity through this process, while sandstones often lose porosity as calcite and silica minerals grow in the pore space. Moving toward the permeability, the ability of porous medium to transmit water is called permeability. It is the ability of the rock to permit fluid flow through the interconnected pores. A rock is said to be permeable if it permits an appropriate quantity of fluid to pass through it in a given time, and it is said to be impermeable if the rate of passage is negligible. So it is a property of medium, only it is independent on the fluid property. 1 Darcy is equal to 1000 milli Darcy is the unit of permeability. Factors on which permeability depends. Permeability is dependent not only on the size of the grains of the rocks but also on their packing arrangements. The lesser packing is expressed by higher porosity, which means higher permeability. The better sorted a sediment is having, the greater its permeability. Tightly packed sediments has a smaller pathway than loosely packed sediments. So the more tightly packed the sediments, the lower permeability. Cementations, compactions, pressure solutions reduces the permeability. This is the water in the pore sediments, water in the fractures, faults and cracks, water in the larger openings like works or caves. Kinds of groundwater we usually found the connate. It is an entrapped brackish water, juvenile water originating directly from magma, metroid, fresh circulating water, which is commonly referred as a groundwater. Qualities of rocks material in respect to contained groundwater. Porosity, that is the measures of water capacity of a rock. High porosity means the rock contains lots of water. This diagram shows the water table well. A well that reaches the water table, the water must be artesian well. A well that reaches the confined aquifers, the water flows due to pressure. Movement of groundwater. Most groundwater moves relatively slowly through rock underground because it moves in response to differences in water pressure and elevation. Water within the upper part of the saturated zone tends to move downward following the slope of the water table. Factors affecting the flow of groundwater: the slope of the water table. The steeper the water table, the faster groundwater moves. Permeability: if rock pores are small and poorly connected, water moves slowly. When openings are large and well connected, the flow of water is more rapid. This shows how groundwater intersect the surfaces. Water comes Water comes out of the ground when the groundwater meets the surfaces. It can be spring, lake, or stream. This shows the groundwater flow.
Excuse me, ma'am.
Yes,
Excuse me,
hello.
ma'am.
Yes,
Excuse me, ma'am.
yes, yes.
Uh,
Hello.
good, good afternoon, ma'am. Actually, your voice is cracking, so I cannot hear actually.
Okay. Now it is okay, sir. Hello.
No, no, it is the same. It is the same.
Vinod, sir.
Ma'am, if it's possible, could you please be a bit louder?
Now it is okay. Hello.
Yeah, ma'am. Yeah, ma'am. It's
Hello.
clear.
Okay. Okay.
Okay,
Okay.
okay,
Okay.
madam. Thank you, ma'am.
Thank you, sir. Yes. So groundwater and surface water connection basically shows in system with high degree of groundwater surface connectivity, high transmissive sediments. A cone of depression dips down, forms along the water table when well is done, and over pumping will lower the cone of depression, which leads to the cave formation. Caves are made up of carbonic acid dissolving cracks in limestone. Caves are a big part of karst topography. Karst topography is a land with lots of caves and sinkholes. So this is the overpumping, the results of overpumping. This diagram shows how rainwater percolates through the joints in the limestones, and differential solutions of limestone is expressed by the depression at land surface that the funnels waters on the enlarged points. Basically, these are the subsiding sinkholes are shallow and forms at the places where the limestone is thinly covered by a soil or where it is overlain by the layer of the soil. This is show how the surface contaminations can directly connect to our water supply. The rural caste reasons, the urban caste reasons, the urban associated with the caste reasons. Now it is okay, sir. Hello.
Yes, ma'am. It's fine.
Now, confined and unconfined aquifer. Confined is the groundwater in an aquifer with the lower and upper barrier of for movement. There is an aqueduct located immediately above and below the aquifers. Zone of aerations, area above the water, that is also called the DOS zone, area above the water table unsaturated with the water and openings filled primarily with air, small amounts of water present by retentions and capillary actions. Capillary actions, the greatest capillary fringe area. Unconfined unconfined groundwater in an aquifer with a lower barrier to the movement caused by presence of an aqueduct below but not an upper barrier allowing water to fluctuate over distance upward. Aquifer and aquifer is a high permeable substance while aqueduct is a low permeable substance. Moving towards the springs, more kinds of spring. Spring is a natural surface emissions of groundwater. Streams can form this way, and many streams like Ozarks are spring fed. A hot spring is about 10 to 15 degree Fahrenheit warmer than polar local annual means air temperature because of an associations of water with subsurface igneous institutions. This diagram shows the interrelationships of groundwater and streams. In some cases, streams can directly supply groundwater and vice versa. An effluent draining stream is supplied by groundwater and abundant in humid climates, a type of springs. An influent losing stream supplies water to zone of saturation and its characteristics for arid climates, not a springs. A spring related to first water table. This arises when there is a groundwater. A spring related to first water table. This arises when there is a groundwater in the zone of variations above the main or regional water table. Pumping of groundwater, heavy pumping can cause poor of depletion of the water from drawdown, may leave many shallower wells dry at the surface. Artesian water, confined groundwater, that is the artesian water, can be a special type of spring. Flowage of subsurface water in a confined aquifers causes a pressure surface level which defines the level to which water can naturally rise. If a surface opening is connected to the aquifer and is below this pressure surface, water can flow naturally at surface, otherwise it is pumped. Groundwater effects in a carbonate rocks, subsurface solutions and precipitation effects due to the chemical mechanisms. Carbonate rocks is dissolved by acid, forming the caves or caverns. Cave precipitates, that is also called speleothems, can form when the groundwater rich in dissolved limestones material becomes less acid. Some famous caves and speleothems are Mammoth Cave, Shenandoah Caverns, Virginia Carsled Caverns, New Mexico's, and many more. The main speleothems are stalactites, which grow from the cave roofs, stalagmites, which grow from the cave's floor, columns, which result from the stalactites and stalagmites merging. More speleothems. Past topography. Past topography is a pitted looking earth surface resulting from subsurface solution actions and include sinkholes and solution valleys. Enormous sinkholes are the examples of mass wastage. This is the saltwater erosion and pollutions. Septic tanks is a Sufeta springs in a spring field is a good example of this. Is another example of septic tanks. Water table, the saturated zone, the subsurface zone in which all the rock openings are filled with water. Water table, the upper surface of the zones of the saturation. What is the Vedos zone? Vedos zone are subsurface zones in which rock openings are generally unsaturated and filled partially with air and partially with water above the saturated zones. Capillary fringe, a transition zone with higher moisture content at the base of Vedos zone just above the water table. First First water table, the top of the body of the ground water separated from the main water table beneath it by a zone that is not saturated. Wells are deep hole generally cylindrical that is dug off drilled into the ground to penetrate and aquifers within the saturated zones, which are the additions of a new water to the saturated zone. The water table in an unconfined aquifers rises in a wet season and falls in dry seasons as water drains out of the saturated zones into the water. This is the cone of depression, a depression of the water table formed around the well when water is pumped out. It is shaped like an inverted cone. It is shaped like an inverted cone. Draw down the lowering of the water table near the pumped well. Artesian well, a well in which water rises above the aquifer, is the artesian well. Springs and streams, a spring, a place where water flows naturally from rock onto the land surface. Some springs discharge where the water table intersects the land surface, but they also occur where the water flows out from the caverns or along fractures, falls, or rocks contacts that come to the surfaces. Gaining streams are a stream that receive water from the zone of saturation. Losing streams are stream that loses water to the zone of saturation. Pollution of groundwater is mainly due to the pesticides, herbicides, fertilizers, chemicals that are applied to the agricultural crops that can find their way to the groundwater when acid or irrigation water leaches the poisons downward into the soil. Rain can also leach pollutants from city dumps into the groundwater supplies. Heavy metals such as mercury, lead, chromium, copper, and cadmium, together with the households, chemicals, and poisons, can all be concentrated in the groundwater supply beneath the pumps. Liquid and solid waste from the septic tanks, sewage plants, and animal feed lots and slaughterhouses may contain bacteria, viruses, and parasites that can contaminate the groundwater. Acid mining drainage from coal and metal mines can contaminate both the surface and the groundwater. Radioactive waste can cause the pollution of the groundwater due to the shallow removal of low-level solid and liquid radioactive wastes from the nuclear power industry. Pumping wells can also cause aggravates groundwater pollution. What are the effects of the ground water actions? Caves or caverns naturally formed underground chambers. So most caves develop when slightly acidic groundwater dissolves limestones along joints and bedding planes, opening up cavern systems as calcite is carried away in a solution. Most caves probably formed by the groundwater circulating catalyze like pendants of dripstones hanging from caves ceilings, generally slender and formally aligned along cracks in the ceilings which act as a conduits of the groundwater. Stalagmites, cone-shaped masses, cone-shaped masses of dripstone forms on the clay floors, generally directly to the calcites. Sinkholes, closed depression found on the land surface underlain by limestones. They form either by collapse of cave roofs or by solution as descending water enlarges or cracks in our limestones. Vast topography and area with many sinkholes with a cave system beneath the land surface. Hot water underground, hot springs, springs in which water is warmer than a human body temperature. Water can gain heat in two ways while underground. Groundwater may circulate near a magma chamber or a body of a cooling igneous rock. Groundwater may circulate unusually deep in the area. A geyser, type of hot springs that periodically erupts hot water and streams. The water is generally near boiling 100 degrees Celsius. This is the Darcy law which defines the groundwater flow. Groundwater development. Multiple pumping wells can cause interference between the cones of depression. Extraction should not exceed recharge. Water mining. Extraction may cause subsidence. Recharge zones should be protected. Ensure adequate water flow. Ensure qualities. Extraction may affect surface water. Many watershed management actions are taken to protect the quality. Hypophilic zone, zone where water is exchanged between surface and groundwater. Controlled by geomorphology, upwelling, downwelling, biochemical processing, water quality and habitat issues, temperature. So reasons for groundwater quality and quality issues are due to the rapid increase in population, growth of industrialization, extensive use of agriculture chemicals, disposal of urban and industrial waste, withdrawal overdraft. Significance of groundwater chemistry, chemistry of ground is an important factors which determine while we use the groundwater for domestic irrigations as well as for industrial purposes. This is the 14th principle aquifer system. Impacts of the groundwater. Pollution versus contamination. Pollution indicates any degradations of natural water quality, while contamination is a result for pollution that creates hazards to human. This is the estimate water balance of the world, which is the surface area, the parameters of the water. World water resources. Hello, am I audible, yes, sir? So a number of researchers have attempted assessment of global water resources. As per estimated, about 96.5% of the total water resources, that is 1,338 million kilometer cubes, occur in the oceans, and only 3.5%, that is 47 million kilometer cubes, occur in the continents. This is the water balance. The global estimates do not show the regional imbalances in the availability and requirement of water due to the variations in climatic and hydrological conditions. Water resources are very irregularly distributed throughout the world. That is Asia, which supports more than half of the world populations, has only 36% of the global water resources, whereas both North America and Australia, which have only 8%, greater than 1% of the world populations, have 15% of the global water resources. It is estimated that only a few water-rich countries enjoy more than 50% of the world water resources. The water demands also varies due to diverse hydroeconomic conditions and population density. This is global water budget, which is estimated around 7 billion people have projected it. The comparative per capita availability of water in 10 major countries, which shows that India has one of the lowest per capita availability of water. Continuous water pollution threatens to reduce the availability quantity of usable water, and more out of our lakes, ponds, river being characterized as polluted due to disposal of industrial and mining waste and a host of human activities. Water resources in India. India has predominantly an agriculture economy, which makes greater demands of water for irrigations with diverse topography, climate, geology, and hydrological conditions. The distributions of available water resources, both surface and groundwater, in the country is highly uneven, both in space and time. The main source of water in India is a rain. As a result, there is a flood in many parts of the country during the June-September period. The same region might experience acute water scarcity during the January-May period. So the annual yields of rainfall is estimated about 4,000 billion cubic meter. This is the zone-wise surface water potential of the India, the potential of surface water and groundwater resources of India. In past, several attempts were made to access the total utilizable water resources of India. Out of total 11,040 kilometer cube of annual utilizable water resources, the utilization in 1919 was 572 kilometer cubes, which comprised 382 kilometer cubes from surface water and 190 kilometer cubes from the groundwater. Due to increasing with the increase in the population, which crossed 1 billion marks at the end of the last centuries, and pace of development, there was a considerable increase of water requirement for various basic amenities and development purposes like drinking and municipal water supplies, irrigations, thermal and hydropower generation, industrial requirement, navigations and maintenance of ecology. In the year 2009, the total utilization of water is around 813 kilometer cube, and projected demand of water for various purposes up to by 2025 is estimated at 1095 kilometer cubes, indicating water scarcity conditions in the next 25 to 30 years. Due to increasing populations, the per capita availability of India is also decreasing drastically. So it is decreasing drastically. This is the potential source of groundwater contaminations and mode of replacement. This is the relative weights of the physical chemical parameters, the Bureau Indian Science Water Quality Standards. This is the methodology to find the physical chemical parameters of the drinking water or any groundwater. The classification of water quality indexes ranges and the category of water. Greater than 50 is considered as excellent water quality. 50 to 100 water quality range indicates good water. 100 to 200 poor water. 200 to 300 very poor. And greater than less than 300 what is unsuitable for drinking purposes. Human health risk assessment is mainly we can subdivide it into four stages: hazard identification, exposure assessment, toxicity dose response assessment, and risk characterization. So in those response assessment for carcinogenic and reference doses are calculated with the US EPA integrated risk information system. In risk characterization, the result of toxicity assessment calculates with the help of risk or hazard results. Exposure of human beings to metals could occur via three main pathways, including direct inhalation through mouth and nose and dermal absorptions through exposure skin. However, inhalation pathway is the most significant for drinking water. The dose received through the pathway considered was determined using US Environmental Protection Agency ADD is equal to ADD is the average daily dose and it is calculated in the mg per kg per day. CW is a geometric mean concentration, that is its unit is mg per liter of heavy metals. IR is the water intake rate, 3.45 and 2.0 liter per day for adults and children respectively. EF is the exposure frequency, which is calculated as 365 days per year. ED is the exposure duration, 70 years for adults and 10 years for children respectively. PW is a body weight, average body weight, 60 kg for adults and 25 kg for children respectively. Risk characterization was quantified by potential non-carcinogenic risk reflected by hazard quotient HQ, which were estimated by comparing exposure or average intakes of contaminants from exposure routes of injections with the corresponding reference dose. If the HQ exceed once, there might be the concern of non-carcinogenic effects. Hazard quotient is the ADD plus reference dose, corresponding reference dose, and it can be originated from risk-based concentration table, US EPA 1993. Risk assessment are multiple metals in the drinking water. A hazard index HI was employed by summing all the calculated hazard quotient values of metals. If hazard index is greater than one, indicated a potential for an adverse effect on human health and a necessity for further studies. So where HQI is the hazard quotient of an individual metals, HI is the hazard index for all the metals that is studied in an area. Carcinogenic risks were evaluated was the incremental probability of an individual developing any types of cancer over a lifetime due to carcinogenic exposure. In this formula, cancer risk, where ADD is a daily intake averaged over 70 years in a mg per kg per day, and SF is the slope factor that is expressed in the mg per kg per day. Slope factor is again originated from the risk-based concentration US EPA 1993. Now moving toward this is the case study of Jamshedpur township area. Jamshedpur is a major industrial center of eastern India. It comprises of companies, more than 1,200 small and medium scale industries. Groundwater act as a reservoir by virtue of large pore space in earth metals. Groundwater contamination is generally irreversible. That is, once it is contaminated, it is difficult to restore the original quality of the aquifer. Excessive mineralizations of groundwater degrades water quality, producing an objectionable taste, odor, and excessive hardness. The main cause of the groundwater pollution is the direct contaminations due to the lateral travel of polluted water. The disposal of waste into the abundant quarries, gravels, pits, etc. can cause groundwater pollution from leachate. The contaminated water requires permanent remediation, otherwise it will affect the health of the consumers. Industry in the Jamshedpur township area discharges their effluents, whether treated or untreated, into the ground and the river. This polluted water leaches down the soil and contaminates the groundwater. So this is the land use land cover pattern of the Jamshedpur township area. An attempt has been done to delineate the buffer of 12 to 10, 20 kilometers by considering Sakchi as a place of gravity of the Jamshedpur urban agglomerations. The dominance of the built-up area around the center of the Sakchi. Physical setup of the city, limits of its scopes, of further northern expansion. Existing land use land cover scheme in the surroundings of the Jamshedpur urban agglomeration suggests that there is a numerous scopes of urban development towards where rain-fed agriculture is practiced. The agglomeration has experienced extensive spatial expansions. However, this urban sprawl is not uniform across the city regions. The city is diverse in nature in terms of governance and infrastructure. Jamshedpur Urban Service Company, a subsidiary of Tata Managers Notified, has made the urban landscape neat, clean, and beautiful with many recreation centers like parks, sports grounds, education, health, and infrastructure. Hello, Vinod sir. Hello. Hello. Shubham
Yes,
sir.
ma'am. Yes, ma'am.
Should the participants need a break of 2 minutes?
Yes, yes, yes.
Okay, okay, sir.
Hello, dear participants. Hello, my dear friends. Can you please tell me, are you, can you hear the sound very well? Is it audible?
Yes, sir. Say, sir. Yes.
Okay, but I don't know. It may be my personal, or I don't know, network or any issue. Actually, I cannot clearly understand the what is Madam going to tell us. I cannot clearly listen that, hear that.
So we are able to
So,
hear it. There is a bit of echo, which after I'm using the headphone, it is a bit better. So you can
ma'am,
try.
ma'am, even you are speaking and your voice is cracking.
Now
Hello,
it is cracking, sir. Hello.
Yes, sir. There's a
hello.
echo problem with the audio. I can understand that.
Is it a technical problem? Hello?
Yes,
Mostly it
sir.
is because
Hello?
of the surrounding.
Is it a technical problem, ma'am?
Sir, it is mostly because of the surrounding where we are in.
No, in my room where I am sitting, it is a quite lab, so it is there is no noise. But
And
what
then
about hello?
sir, I'm talking about at our end because we are in classrooms or in halls which is empty and taking the
Yes.
Yes, sir.
sessions.
It is
So
empty, sir. It is maybe
there's
echo
a
is
issue of
coming.
echo.
Okay.
Now it is
So
clear, sir. Now it is clear.
okay,
Hello.
not so very good, ma'am.
Okay.
So actually, since I cannot hear, so I'm not. I don't understand.
Should we start, ma'am? Hello, Vinod sir, should we start?
Yes, ma'am. We
Okay.
will start.
Yes, sir. This is the drainage pattern of the Jamshedpur township area. Jamshedpur is located at the confluence of Kharkhai and Swarnrekha rivers. Swarnrekha is the principal river of Jamshedpur, which flows from west to southeastern part of the territories. All the tributaries of this area meet with the Swanrekha River. Major tributaries which meet the Swanrekha River from west to east are Sapnara Nadi, Ganga Nadi, Dugh Nadi, and Chagdhan. Drainage pattern is dendritic in nature. Drainage of Patamda blocks do not meet in Swanrekha River. Kharkhai flows from the south and joins the Swanrekha rivers at a place called Domuhani. The two rivers are the major source of drinking water and groundwater for the city. Several lakes of varying size are also located near the fringes of the city. The major of them being the Dimna Lake located in between the Dalma Range and Sitarampur Reservoir beside the Kharkhai River. This is the hydrogeochemical classifications and hydrogeochemical facies. Several factors such as geological structure, existence of earth crust mineralogy, anthropogenic activities, and diverse climatic conditions control groundwater chemistry in the Jamshedpur township area. This is the positive linear relationships for calcium and magnesium versus total cations indicate major source of calcium and magnesium ions in the groundwater, where weathering of carbonates minerals. This linear relationships for bicarbonate versus calcium plus magnesium reveals weathering of minerals involved in the concomitant production of bicarbonate ions from dissolved carbon dioxides and reactions of rock minerals in presence of H2O CO3. This is the calcium magnesium. This graph is a linear relationship graphs derived from carbonate weathering, but also the release of calcium and magnesium by silicate weathering, or the possible source by reverse ion exchange, which is the evident from the relationships between bicarbonate plus sulfate versus calcium and magnesium. The Gibbs diagram was plotted by using total dissolved salt concentration versus weight ratio of sodium divided by sodium plus calcium for cations and weight ratio of chlorine divided by chlorine plus bicarbonates for anions. The Gibbs diagram shows that rock weathering is the dominant mechanism controlling the major ion chemistry of groundwater and anthropogenic activities in the Jamshedpur township area. The constituents of TDS are derived from the rock-water interactions, that is the weathering of carbonate and silicate clays present in the granite and gneiss rock. The majority of groundwater sample fell in the rock weathering region, indicating that the groundwaters are found in the recharge and flow through areas where water-rock interactions control the groundwater chemistry in the Jamshedpur township area. The geochemical process might be triggered by rainwater infiltration through the soil profile and bedrock, leading to the desorptions of iron in the groundwater system. This is the Piper trilinear diagram. Is very useful in determining the relationships of different dissolved constituents and classifications of water on the basis of its chemical characterizations. The triangular cationic field. This is the triangular cationic field of the Piper diagrams reveals 40% of the groundwater samples fall into no dominant class. About 45% of the samples fall into the calcium field, reveals the calcium source of calcium may be from the weathering and dissolutions of calcium bearing sedimentary rock. The magnesium field is about 10% of the sample and 5% sodium by potassium field. In anionic triangle, the majority of samples, as in the 52%, fall in the chloride field, which suggests that major source of chloride may be from the domestic sewage. About 40% of samples fall in a no dominant types, where 5% of the sample fall is in the sulfate field. The plot on the chemical data on the diamond-shaped central field, which relates that the cation and anion triangles, reveals that the plotted points fall in the field 1, 2, 3, and 4 in all groundwater samples. Alkyne earth metal, that is the calcium plus magnesium, exceeds alkali metal cations, that is the sodium and potassium. There is dominance of strong acid, sulfate and chloride over beads in the Jamshedpur township area. About 50% of the sample fall in the field of calcium magnesium sulfate types, which shows non-carbonate hardness of the groundwater. About 44% of the sample fall in the field of the calcium magnesium chloride types, reveals mixed nature of the groundwater, having non-cation and ion pairs dominating the chemical compositions. And about 4% of the samples fall in the calcium magnesium bicarbonate types, which suggests that the groundwater presence is having carbonate hardness. About 2% of the samples in the sodium chloride type reveals the mixed characters of the groundwater. Based on the dominance of different cations and anions in the groundwater, two hydrogeochemical water types can be defined as calcium magnesium sulfate and calcium magnesium chloride. Now, this is the water quality which is used for irrigation uses in the Jamshedpur township area. The ion exchange between the groundwater and its host environment during the residence or in movement process are the important controlling factors for the water chemistry of the region. The ion exchange process can be understood by chloroalkali indexes, also known as Scholar indexes, and it is expressed by chlorine minus sodium plus by this equation. It is given here. So Scholar index. Yes. The chloroalkali indexes can either be positive or negative depending on whether exchange of sodium and potassium is from water with magnesium and calcium with, mag- with magnesium and calcium in rock, soil, or vice versa. If sodium and potassium are exchanged in water With magnesium and calcium, the value of the ratio will be positive, indicating the base exchange phenomena. The negative value of the ratio will indicate chloroalkali disequilibrium and the reaction as the cation and ion exchange reaction. During this process, the host rocks are the primary source of dissolved solids in the water. In present case, about 33% of the groundwater samples have negative values, revealing chloroalkali disequilibriums and the reaction as the cation ion exchange. In 67% of the samples, the values are positive, indicating the base exchange reactions. The sodium or alkali hazard expressed with this formula, and it also shows the whether the water is used. Because 38% of the sample fall in this C2S1 categories, indicating good to permissible qualities of water for irrigation uses, and about 62% of the samples fall in the C3S1 category, indicating high salinity and low alkali water. This is the percent sodium, which is determined by this formula. This is also the Wilcox plot diagrams relating electrical conductivity, and percent sodium shows that the water samples fall in all the classes. About 42% of the water samples are excellent to good, and 58% of the good to permissible quality, which may be used for irrigation purpose without any hazard. This is another formula for checking the water quality for irrigation uses. The permeability indexes for assessing the suitability of water for irrigation uses. Soil permeability is affected by long-term uses of water enriched sodium, calcium, magnesium, and bicarbonate. Cayley index and the magnesium hazard is also used in the classification of water for irrigation. Water with less than 1 Cayley ratios indicates excessive level of sodium and is unsuitable for irrigation purposes. And when it is greater than 1, it is considered as a suitable for irrigation. The Jamshedpur townships, the ranges of the Cayley indexes is the 0.15 to 2.0, which with the mean values of 0.36, thus 95% of the groundwater sample are suitable for irrigation uses based on the Cayley indexes values. This is magnesium hazard formula. Is the excess amount of magnesium over calcium and magnesium. The excess of magnesium affects the quality of soil, resulting in the poor agriculture returns. A magnesium ratio greater than 50% is considered harmful and unsuitable for irrigation. The groundwater having the magnesium hazard value 6%, 24 with the mean of 32%. Since 14% of the groundwater samples have magnesium hazard value greater than 15%, which makes it unsuitable for irrigation purposes. This is the metal distribution, a spatial distribution of the trace metals. Of for 14 metals of the groundwater, whether it is hello.
Yes, ma'am.
Is it clear, sir?
Hello. 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 Hello.
Hello.
Hello. Yes, ma'am. I am Dr. Subroto Kumar Devnath. May I ask May I ask some questions at the end of the session of your session, please?
Yes, sir. You can ask, sir, at the end of the session.
Okay, okay. Thank you, ma'am. Thank you. Thank you.
So this is the total dissolved metal concentration in the groundwater, the metal distribution, how it is distributed. The highest concentration of iron and manganese was noted in the sampling locations at the different of the Jamshedpur township area. So, how we can manage the groundwater management in the Jamshedpur township? The Jamshedpur Utilities and the service company JUSCO is an integrated urban water service provider managed under a corporate framework. It was set up as a wholly owned subsidiary of Tata Steel and became operational in 2004 with the transfer of employees from the Tata Steel Down division. Within a few years, JUSCO achieved a substantial improvements in its service delivery and operational efficiencies. It has evolved into a one-stop integrated utilities providing in a range of areas including water and wastewater management, construction, municipal solid waste management, power, and integrated facility management. The other utilities attempting to leapfrog from mediocre to moderate level of performance to better service delivery standards. It's offer encouraging insights for applications in governance, operations, technologies, and management practices to provide equitable and affordable service in a commercially and environmentally sustainable manners. Water sources and availability in Jamshedpur. Raw water is extracted from the surface water sources, mainly from Swanrekha River and Kharkhai rivers. While Swanrekha is the prime source of water, Kharkhai is the tributaries of Swanrekha and act as a divider between JNA and NNA. The Swanrekha River is a perennial water source and it is jointly used by both JISCO and Public Health Engineering departments. During the times of low water levels in the Swanrekha River, particularly during the years of poor monsoon, JISCO can utilize water in its own standby reservoir at Bimna. This reservoir is constructed in 1944 at a distance of 8 km from the cities and it has the capacity of about 34,000 ml of water. Water quality, JUSCO takes pride in being among the few utilities in India to assure and meet a drink directly from the tap level of potable water quality in its network. It has managed to achieve continual improvement in water quality. More than 99% of the potable water sample tested for bacteriological qualities and free chlorine conform to the BIS norms. JUSCO has initiated a number of systems and process-related initiatives that played an important role in improving its water quality and environmental management. Moreover, in water laboratory in Jamshedpur is the first among India's water utilities to be certified by the National Accreditation Boards for Testing and Calibration Laboratories, that is the NABL. It analyzes over 5,000 water samples from customer taps, storage tanks, treatment works, and water tankers annually to ensure then its water quality conforms to BIS and WHO guidelines. Water quality parameters are monitored regularly. Metering is another undertaken initiative to meter water connection in the Jamshedpur. The objective is to identify and reduce losses in terms of leakage and unauthorized tapping to improve efficiency in service delivery and to establish water balance. Rainwater harvesting in Jamshedpur, where groundwater resources are scarce and rainfall is uneven across the year, special attention is given to the establishment of rainwater harvesting system. JUSCO has implemented various rainwater harvesting systems in several locations, including local schools, residential colonies, and housing complexes. Roof runoff is collected through downcombers and ground runoff through underground collection chambers. From the recovery chambers, water is pumped to the head tanks on the tops of buildings that are isolated from the potable water tanks. Now, wastewater treatment, there is 100% sewage collections and treatment before disposal within the lease areas. The treatment is based on the conventional activated sludge process and extended aeration process. The treated effluent exceeded the standards of Jharkhand State Pollution Control Board as part of JUSCO river to river philosophy. A portion of the treated wastewater is reused within these industrial units in the Jamshedpur, and the balance is released into the river downstream. A portion of the solid sludge is sold as a fertilizers to some adjoining rulers and the agriculture. In this note, sir, I have completed my presentation, sir. So this is the method of groundwater recharges. For rainwater harvesting system, following structures are required: storage tanks, recharge pits, recharge trenchers, abnormal plug wells, abonded hand pumps, recharges, vertical recharge shafts, natural shafts with bore-wells. Yes, sir. Hello, Vinod, sir.
So the session is open for discussion.
Yes,
Yes.
sir.
Good afternoon,
The
ma'am.
session is
And
open for the discussion.
Good afternoon, sir.
okay. Good afternoon, ma'am, and good afternoon to all my dear participants and friends and all the coordinators. I have some questions regarding the topics the madam was telling. And in the very first, actually, I could not hear, so I could not got all the points. But there was some technical problem. That is why I could not understand everything. But whatever I have understood regarding on that, I have some questions. I want to know from all the participants and ma'am that first question is, I think MAMP is mainly concentrating on the water problem. Am I?
Yes, sir.
Am I correct, ma'am?
Yes, sir. Groundwater problem.
Okay, groundwater, contamination and all other things,
Yes.
water level and all other things. But I want to say something about me. Actually, I am from mathematical background, so I don't have so much technical knowledge in chemistry, geology, and civil engineering. But from the general sense, I am asking you some questions. That the main thing is the source of water. The source of water can be mainly, so far as I understood, there are two sources of water. Number one is the underground water, and number two is the surface water. And this surface water are actually coming from the rainfall and all other things. So, if we consider,
From aquifer. Yes, sir. Yes, sir.
sorry, ma'am, I cannot hear it.
The source of underground water is the aquifer, right, sir?
Okay, so if I consider on underground water, then underground water contamination is a big problem of at least some region in India. And I am speaking from Kolkata, and near the Kolkata, the Barasat subdivision of 24 North PGS is especially affected by, arsenic contamination. And that is a big problem for the scientists and the government also. So many initiative has been taken to solve this problem. But one of them, my question is, see, I am using some underground water by deep tube well or whatever it is. Okay, I, as a household man, we don't understand whether my water, whatever I am using from my house, is contaminated or not. Because I don't know it. I am taking the water from the tube well and I am drinking it. So for a general people, it is not possible to understand whether my water is contaminated or not. But in West Bengal, there are some organizations who test the sample. That organization do the sample test. Okay, and that sample test is done through any institution.
Yes.
Okay,
So
but
water,
individual.
yes, sir. Water pollution, sir, in mining area is mainly due to the dewatering, which is
Sorry,
undertaken.
ma'am. Sorry,
Yes, sir.
ma'am. Sorry, ma'am.
Water pollution in the mining area, sir. Mining area is mainly due
Yeah.
to dewatering, which is undertaken to make mining possible. And second is due to the seepage of contaminated leaches from the waste rock pipes and tailing dams. Are you
Uh,
sir? Hello?
hello.
And
Actually, I cannot.
flooding of workers.
Sorry, ma'am. I can. Sorry, ma'am, I cannot hear you due to your voice is just cracking so much that I cannot hear you. Sorry, ma'am. Anyway, I can personally talk to you, or else if I get the video,
Of
if I
course,
get the video,
I want to say
if
you,
I
sir, water pollution in if you are listening,
You can get the video,
if you are
Subrata.
listening, sir, just
hello,
listen. Water pollution in
You
mining area is mainly due to the dewatering and seepage of contaminated leaches from waste rocks. Yes, sir. And flooding of workings after extraction has ceased in the mining area. So discharge of untreated water after flooding is completed. Mine water pumped out from underground and open cast mines. Leaches, washes off from overburden and solid waste deposits. So these are the main cause. And wastewater from coal waste or related industry is also the main source. So municipal waste from human settlement is also one of the reasons for mine water pollution. You can talk to me, sir, through mail. I can give you details. Vinod, sir, please provide my mail ID, sir.
yes, ma'am.
Yes. Any more doubts?
Any if you
Ma'am,
want to
there are some
ask
questions in the
question,
chat box also.
Okay. Let me see.
hello, hello.
Yes, sir.
Again, I am Dr. S.K. Devnath, but still the problem is happening that I cannot hear. So I am not disturbing you asking so much question, but I have so much questions about that, and I have some suggestions also. So we can think about how to solve the problem case wise or a global way.
Yes,
So
Dr.
we can
Subrata,
discuss later also.
Dr. Subrata, you can mail also. You can
Sure,
share
thank you, sir. Thank you, sir. So I will
mail.
mail my questions and my suggestions to you.
Yeah, yes,
So
yes.
we can. Okay. Thank you, sir. Okay, thank you.
so Darcy law is basically is a
Ishi ma'am.
let me share. Yes, sir. Yes, sir.
Nisi ma'am,
Yes, sir.
Nisi ma'am.
Yes, sir.
Ma'am, there
Yes,
are
sir.
some questions in the chat box. Hello.
Yes, sir. Yes, sir. I'm seeing, sir. I'm seeing. Hello.
There are some questions in the chat box.
Yes, Darcy law is basically to measure the groundwater flow, the permeability of rocks that may be expressed in terms of velocity, in terms of discharge or quantity of water that passes through a unit area of a cross section in a unit time. So one Darcy is a 1,000 millidarcy, and it is a unit of permeability. Another question. is the behavior of cyanide with groundwater? It definitely harms the human health. Cyanide, maybe it is anthropogenic, maybe the area with the industries that are releasing this, it's mainly the coal, I think coal area. I didn't work in cyanide, so I don't have much knowledge about this. So let me check and I will tell you. Provide me mail ID, sir. You know, sir?
Yes, ma'am.
Yes, sir.
There is a feedback form in chat box. Please fill the feedback. Attendance come feedback form. Dear participants,
Okay, excuse me, sir.
yes,
Excuse me, sir. How can I give the attendance and the feedback? Please tell me.
there is a one or two question for the through the contents and one other question from the your when you give the feedback and then you also give the attendance.
So where is the feedback form is available?
Yes, in the chat box.
Okay, but can I do it later also?
Yes, yes, sir. Yes, sir.
Okay, I'll do it later because there is some technical problem here.
Okay, okay. It's
And what about the previous sessions? I also did not give the attendance because there was some technical problem here.
okay, okay, okay.
Okay, okay. Thank you, sir. Thank you.
Okay. Okay.
Thank you so much, sir.
Suman, sir.
Yes, sir. Hello.
Yes, sir.
Yes, sir, we can close the session.
Okay, sir.
Yes, yes, yes.
Thank you, sir.
Okay, thank you all. Thank you, my dear friends and madam, and see you in the next day. Thank you, madam. Thank you all.
Thank you so much, sir.
Thank you so much, Risikant ma'am, for giving nice lecture on water contamination. Tomorrow session will be started on 10 a.m. It will be the resource person, Dr. Ram Krishna sir from BIT Chhattisgarh. So please stay with us. Thank you so much for attending today's session. Please fill the feedback form. There is a chat box.